Select the structure of the repeating unit formed by the free radical polymerization of vinyl chloride. So when we're looking at a monomer such as vinyl chloride, where you've got this ethylene unit, typically this polymerization is going to be an example of what is known as a chain growth polymerization. And so when you have a chain growth polymerization, you need a way to take that alkene and make it into a reactive intermediate, such as a free radical. And for these chain growth polymerizations, we can usually recognize that this ethylene unit is going to be the backbone of the polymer. And so if we draw just a generic ethylene, and I'll just use X in place of that chloride, when you do the polymerization, you end up with these two carbon units or carbon atoms over and over again as your repeat units in the polymer. And when you make that reactive intermediate, in this case it would be a free radical, we'll take a look at the actual mechanism in a moment, but when you do this process, the alkene itself reacts. So in your repeat unit, the alkene is no longer present, but you can still pick out those two carbon atoms. So you would be able to see as your repeat unit that backbone, and the remaining bonds to those two carbon atoms is going to be to the rest of the chain. And so you just see over and over again the two carbon atoms of that backbone. So we should be able to pretty quickly actually pick out the structure of the repeat unit. The only thing we have on our alkene in this case is the chlorine. So if we say carbon 1, carbon 2, we can see that we've got that repeat unit here in B. So we can pick that out, and now let's take a look at how this polymerization actually occurs. So when you have a free radical reaction, you need to have some sort of free radical initiator, and that's often a peroxide. So some sort of free radical initiator like a peroxide. So you've got that weaker oxygen-oxygen single bond, and so this can cleave, usually in the presence of heat or light, and give you free radicals. And this will be the free radicals that you're going to need to get the reaction going, to get that chain reaction proceeding. And so once you've got a radical, that can react with one of your monomers. So we'll draw this vinyl chloride monomer. And so that free radical initiator can react with the alkene. So we're going to take one electron from that radical and one electron from the alkene. So we're forming a bond between this oxygen and this carbon. And then we're going to put a radical on the other carbon atom of the alkene. And so this is how we transform our alkene into that reactive intermediate. So we will see the initiator present at one end of the polymer chain. And so now we've got a new free radical. So this is a propagation step. And this new free radical can react with another monomer, another of the vinyl chlorides. So we can draw another vinyl chloride here for this to react with. And we'll show this as another propagation step where you're taking a radical and you're forming a new radical. So this can react in the exact same way the radical initiator reacted with the first vinyl chloride. So we're going to end up forming a bond now between these two carbon atoms, and then we'll get a new radical. And in this way, we'll have a new reactive intermediate, and every time we repeat this process, the polymer chain is going to grow. Right, so we've got a new radical, and this reaction just can keep on going, and this is where we can recognize that repeat unit in there, because we're going to keep seeing these same two carbon atoms over and over again.